Hello friends, welcome to Risingpearl.com. Today we are talking about series 13 where we're learning a great deal on surface areas and volumes. This is webisode number 11 and today we are going to find out how to solve questions on surface areas of a combination of solid figures. This is part 2. Part 10, the last webisode, we started part 1. So let's take a look at some more questions in this webisode. So a toy is in the form of a cone. We have a cone of a certain radius mounted on a hemisphere. So looks like we have a cone which is sitting on top of a hemisphere of the same radius. So what we know is the cone has a radius of 5 centimeter and the hemisphere has the same radius of 5 centimeter, and cone is sitting on top of a hemisphere. The total height of the toy is 17 centimeter. Find the total surface area of that toy. So first thing we notice is there are no figures or shapes given. So we draw ourselves a cone. This is a cone and then we have a hemisphere, and our cone is sitting on top of a hemisphere like this. So let's take a look at what all things we already know. This radius is given to us, r. Now the base circle of the cone, that radius is same as the radius of the sphere because it is given they both have same radius, right? That means the cone exactly sits perfectly, it fits and sits on top of the hemisphere. They both have the same radius. Also what is important to note is that this height is given. So if we were to think it like this, so if this is the height of the cone, let's say this is lowercase h, this is the height of the cone, right, from the top to the base of the cone. And what is this height? This height is nothing but this is the radius of the hemisphere, so this is r. So what is given in the question is that the total height, we're writing it in abbreviated form, the total height of the toy is given as 17 centimeter. Total height. But total height is nothing but h plus r, right? This is h, this is r, this is the total height, h plus r. So this is given as 17, or h is equal to 17 minus r. R is given as 5. The value of r is given to us as 5 centimeter. So it will be 17 minus 5, or in other words this will be 12 centimeter. So the height of the cone is 12 centimeter. So at this point, friends, we know the height of the cone, right? We know the radius of the cone and we know the radius of the hemisphere. So essentially we have all the measures for both the cone and the hemisphere. Now what is important to understand is that what is the total surface area of the toy? Now one thing that I would like to make sure that you understand this very clearly is that the total surface area, whenever I want you to think this way, whenever you think about surface area, think about the area that you need to apply paint on, right? So for example, this is a toy and this is a blue color toy. So we want to paint this toy red color. So what is the total surface area on which I need to apply the paint, right? So now the area on which we have to apply the paint will be the curved surface of the cone, which is the top of the cone, and the curved surface area of the hemisphere. What is most important to understand is this part that I'm highlighting right now. This part should not be the one that I shaded just now. This should not be part of total surface area, because this part is basically getting covered inside the toy, because the base of the cone and the top of the hemisphere, they basically both exactly fit, and that is the part which is inside of the toy. So if I were to think about painting the toy red on the outside, I will not worry about this inside part. meaning that when now we apply the total surface area, we know that a cone has two areas, right? Cone, if you just think by itself, total surface area of a cone, we have seen this earlier, is the curved surface area of the cone plus the area of the base circle, right? Area of the circle. What is important to understand is that this area of circle we will not apply. Why we are not going to apply the area of the circle? Because that is inside the toy. So we are going to be only considering the curved surface area of the cone, and similarly we know for the hemisphere the same thing. It is the curved surface area which is outside that we need to apply the paint on, and the top of the hemisphere is again inside the toy, so we don't actually worry about that. So let's do one thing, let's just clean this up and write it a little bit more clearly. So what we actually need to do is that now the total surface area, let's call this TSA, total surface area of the toy will be equal to the curved surface area of the cone plus the curved surface area of the hemisphere. This is very, very important to understand, that you actually get this point, right? We are not factoring in this part that I'm shading again, because this is inside of the toy. If I have to paint this toy red, I'm worrying about, or I'm thinking about only the outside of the toy, which is the curved surface area of the cone. Let me see if I can actually show it this way. This is the curved surface area of the cone, and similarly it will be curved surface area of the hemisphere. So now we need to find out, we need to calculate, now that we have established what is the total surface area of a toy, which is basically sum of these two. Now we have to find out this individual values. So the curved surface area of a cone, so the formula for that is pi r L. Now what is L? L actually is this curved length. Actually it is called slant height. This is L, right? And the height of the cone is h, which is from here to here. This is h, and the radius, which is over here, this is r. So we can think of this as a right triangle. So this one, and this one is a right triangle. So in other words, let's do it here. L square is equal to h square plus r square as per Pythagoras theorem. H is 12, so 12 square plus 5 square, which will be 144 plus 25, which will be, let's do it here, that will be 169. So 169 will be L square. Now if you square root both sides, 13 square is 169, so from there we get L is equal to 13 centimeter. 13 square is 169, so 13 square equals L square, so L equals 13. So going back to our formula, so this one, area of the curved surface area of the cone will be pi, r is 5, L we just found out is 13, or this will be 65 times pi centimeter squared. So the curved surface area of the cone, we have just found out the curved surface area of the cone, 65 pi centimeter squared. So now let's do one thing, let's clean this up. We've got a lot of stuff going on. Now the curved surface area of the hemisphere. So the curved surface area of the hemisphere, we know that formula, that is actually equal to 2 pi r square. 2 pi r square, or in other words, let's see if we can actually write it a little bit more clearly here. The L was here, this is a slant height, and this was h, height of the cone, and this was r, so this was a right triangle. So this is a right triangle, And so applying Pythagoras theorem, we had L square equals h square plus r square. That is how we got L equals 13. Just wanted to make it clear over here. So now we are talking about the hemisphere. So curved surface area of the hemisphere is 2 pi r square, or 2 times pi times r is 5 square. Now 5 5s are 25, 25 2s are 50. So this is 50 times pi centimeter square. So the CSA for the hemisphere, or the curved surface area of the hemisphere, is 50 pi centimeter square. So the total surface area of the toy will be equal to curved surface area of the top, which was the cone 65 pi, plus the curved surface area of the hemisphere, which is 50 pi. So if you simply add them, you will get, 5 and 6 5 11. So it will be 115 pi centimeter square. So I'm not actually going to simplify this anymore, but you can definitely do it of your own. So just replace pi by 22 by 7 or 3.14 and just calculate in terms of decimal what this value should be. But this is the answer for this much centimeter square will be the total surface area of the toy. So just wanted to highlight what we have already discussed before. So whenever we solve these kind of questions, we want to visualize which simple solids make up our given complex figure. That is, are we combining cuboids, cubes, cylinders, cones, spheres, hemispheres, etc. So in this particular example, we were combining cone plus hemisphere, right? So the first step is basically to visualize which simple solids make up our given complex shape. The second step is to find out which areas need to be added and or subtracted. This is very important. Like the way in the example we realized what we need to basically add the curved surface area of the cone and the curved surface area of the hemisphere to find out the required area. So the second step is to make sure we understand which areas we need to add and or subtract. And the third and the final point is to find the individual areas, right? So we actually have to find out the curved surface area. So the way we did that was that we applied for the curved surface area of the cone. We know that the formula is pi RL. So we actually calculated the curved surface area using this formula. And similarly, the curved surface area of the hemisphere for our given problem. So we use the formula 2 pi r square. So the third step is telling us that calculate the areas of individual solid figures. So for us this was the 1 and this was number 2, and then calculate the required area. So using the information from step 2, for us the total area was 1 plus 2, and we got 115 pi centimeter square. So this is how we solve these type of questions, and we are going to look into more examples in the next few episodes.